everybody. Let's finish this up, okay? The I will statement for this section is I will find the volume of prisms and cylinders. So this is chapter 10, section 6, and we're doing volume of prisms and cylinders now. We just finished surface area, lateral and total. So let's go on here. Once again, Miss Scott and I were nice and gave you all the formulas so you didn't have to write them down or draw the figures. I know you can tell us thank you later. Anyway, let's review them. Excuse me. The formula for the volume of a cylinder, this is whether it's a right cylinder or oblique. It works either way. You have to find the volume of your base, okay, and not the volume of your area of your base, sorry, the big B, times the height of your cylinder. And please don't forget, height is the perpendicular distance from the top to the bottom, okay? So if they don't give you that, if they give you this over here or something, you're going to have to find a way to find it. Then, of course, you're familiar with the volume of a cube is S, or side cubed. The volume of a rectangular prism is length times width times height. Now, this looks familiar because it looks like the slant height L, but it's not. This is length on this one, okay? You may want to make a note. On other oblique and right prisms, this is the formula, which is area of the base times the height. If you think about it, it's the exact same thing here. Area of the base is length times width, and then you use your height. So it's either way, big B times H. Here you have to figure out what is my base, what is the shape of it, and what formula do I use to find the area of my base. In this instance, it is a triangle, so I'll use 1/2 base times height, okay, which is where they got this over here, and then the height of your full prism. Now, keep in mind, if this is my base, that means I could stand it up on its end, which is why this is my height. Okay, so keep that in mind. All right, then down here are a couple of examples we wanted you to have. It shows how a scale factor being placed on all the dimensions changes the volume, okay, what the effect is. So keep these in mind. Please look through that, highlight anything that you need to, maybe even highlight your base right here, okay? That way you know what they're talking about, and it has a good example. All right, so once again, fold your little foldable there, okay? Just like we did earlier, blank side on the inside, then you fold it in half again. So you should have problem number 1 here on the front, okay? So you remember when we were talking about surface area? Okay, and we took out the bottom of the little cylinder here in a composite figure. You don't have to do that in volume, okay? Volume is just how much space is inside. So we're going to do volume equals big B, which is the area of the base, which is where I got pi r squared, times H. So you just fill it in. There's your radius, there's your height. You get 16 pi for an exact answer, or about 50.27 meters cubed. Don't forget, anytime you round, you need to put the squiggle in front of it so that it means about. Okay, it's not an exact figure. And then when you do the prism, this is a rectangular prism, so you can use length times width times height, multiply them all together, and find your volume, which is 150 meters cubed. You add them together. If they want an exact answer, this is your answer, 16 pi plus 150 meters cubed. Or if they want it rounded or an about answer, you go ahead and multiply this out to a decimal, add them together, and you get 200.27 meters cubed. And you're right, I should have put a squiggle in front of that. I'll have to fix that one. Okay. Then on this one, this is where we're going to start working with dimension changes. Notice it says the dimensions, more than 1, are multiplied by 2. Okay, well, remember, in this case, always find the original unless they've given you an original volume. Find the original volume using their original dimensions. That's a 7, by the way. So you have 7 times 2 times 5, length times width times height, and you get an original volume of 70 inches cubed. Then go and multiply everything by the scale factor, find your new dimensions, and just plug those in. 14 times 4 times 10, and you get the 560 inches cubed. Now, if you remember when we were doing surface area, I said you could do a fraction here, new over the old, in order to find out what the new scale factor was. So 560 to 70 equals 8. So my volume was multiplied by 2 cubed, or 8. It follows the rule that if you have a units cubed answer, you can multiply it by the scale factor cubed, or yeah, in that one, scale factor cubed, to get the new volume, okay? This one down here, I know you can do all on your own. It even gave you dimensions that are easily divisible by the 4, or multiplied by a 4th. So find your original, and then find your new, and then tell me what the new one was multiplied by. Okay, so divide new by old, and give me the new scale factor. Okay, so let's do this last example. This one looks a little crazy, doesn't it? Don't forget, if you want to, you can go ahead and pause me and write it all down, but make sure you come back and listen to the explanation, because I can promise you, you will see this problem again, okay? It says, find an expression for the volume of the figure below in terms of x. Simplify fully. Okay, well, in this case, we have an equilateral triangle here, hence all the little tick marks. So this is our base, and then we have one back here that I can go ahead and highlight for you. Okay, so you may want to get in the habit of going ahead and highlighting your bases so that you're never confused about what you're using. Okay, so if this is equilateral, each side equals x. If this is my base and I can stand it up, then that is my height. All right. Well, we need to find the height, and the way we do that is to pull out the little right triangle. Okay, and then this is an equilateral triangle, so we can use a base angle of 60. I'm going to put my little right angle. It's a special right triangle, so we have a short leg right here, hence the long leg. So the height is going to be short leg times square root 3. Remember? Okay, now we have everything we need. We plug it into area equals 1/2 base times height. 1/2 times the base of the full triangle right there times the height. And then when you combine them, don't forget, everything not under a fraction is on top and gets multiplied together. X squared square root 3. Everything on the bottom gets multiplied together, so you get 4, and that's the area of your base. Then you come back over here. The area of our base we just found, which was x squared square root 3 over 4, times the height, which is x plus 1. These are multiplied together, so your answer is not simplified yet. You have to distribute, just like you've always done in the past. Just now you're much more advanced and can do bigger numbers. So here, x squared square root 3 times x gives you x cubed square root 3 over 4 plus, hence the plus, multiply this whole piece by the 1, and you get x squared square root 3 over 4. This is your completely simplified answer as the volume of that prism. And actually, I should put units cubed on there, okay? All right, so that sums up all of our notes for chapters 10.4 and 10.6. Make sure that you go over these so that you are ready to finish your application tomorrow, okay? Whatever questions you have, write them down and we will go over them in class. So have a wonderful rest of your day, and as always, enjoy doing your math.